So guys, okay, I think I'm live, right? I think I'm live, and I have just like done something to my audio also. So I don't know whether it sounds good or not, but I have like have a little bit of compression on the audio so that it sounds better. So just guys over here, if I'm live, if you can see me, just give me a thumbs up or something like that. Okay. In that case, I'll just start with the video real quick. So I'll just pin this. Okay, so it's over here. Sorry. Pin message. Yeah. So okay. So am I audible? Sorry. Pin message. Yeah. Okay, so I'm perfectly audible, right? And I'm thinking that I'm assuming that my audio is also better. Okay. There may be a little bit of like discrepancy in the video, a little bit, because like I am using my laptop camera only, and I know that the laptop camera is not that good. So it's a mild request that I'm assuming that so people who have just joined, just tell me if you guys can see me as well as hear me or not. Okay. So let's start with today's video. Gemini and ChatGPT. This the last problem I was trying. I could do only 3 test cases. I don't know where the other test cases were failing, but yeah, that was a good problem though. Okay. So let me just pin the comment section also. Okay, so this is the obvious thing, no? This is the obvious thing. So let me just pin my comment section. Okay, now I think it's properly, everything is proper. Okay, so I'll be explaining the 4 questions of this contest. Okay, are there any people in the lobby though? I don't know. People, if you're guys, if you're there in the lobby, just tell me just message something. Okay, just write a hi or whatever, so that I'll just start with the video directly. Okay. Okay, I'm just assuming that you guys are ready only. Okay, so I'm just starting with the video directly. So let's open Excalibur. Okay, so let's go with the first problem. Okay, the first problem was the butterfly problem. Okay, so it is given that in your garden there are exactly are butterflies. Let me do one thing. I'll just put this. So it was given that in a garden there exactly are red butterflies, G green butterflies, and B blue butterflies. Okay, there also exactly are red flowers, G green flowers, and B blue flowers. Right? So you have to determine whether it is possible for every butterfly to feed on exactly one flower or not. Hello. I didn't notice you though. Okay. Hi. So you have to determine whether it is possible for every butterfly to feed on exactly one flower or not. And so that no two butterflies feed on the same flower. Okay. Each butterfly feeds on a flower whose color is different from its own color. For example, a red butterfly can only feed on a green and blue flowers and not red flowers. So let me draw it for your better understanding. So it will be like this. Okay, so let's say we have a red butterfly So it can sit on a green flower. Just ignore my drawing. Actually, the butterfly, you won't get the difference between the butterfly if I draw like this. So let's say there is a red butterfly. A red butterfly can sit on a green flower. Okay, or a yellow flower. Or, was it yellow though? Or I think blue. No? Yeah, it was blue. Sorry, or a blue flower. Okay, so basically we have to find out whether we can place all the butterflies or not. Okay, I think this is my camera. Yeah, sorry. So basically, I think it's better like to shoot with this only because you guys can see me directly, right? So it's better. So basically, a butterfly can sit on either of them. Okay, on either of them. Let me go to shift to black. A butterfly can sit on either of them, this or this. Okay. Now the color goes on like the butterfly can be red also, the butterfly can be blue also, the butterfly can be green also. It doesn't matter. Now, if let's say, now we have to find out whether it is possible to make it or not, make a such situation or not. So let's say what if. So first, I am going to focus on what if it is not possible. So let's say there are 8 red butterflies. Okay, there are 8 red butterflies, one green butterfly, and one blue butterfly. Right, which means that there is also one green flower, one blue flower, and 8 red flowers. Right, now for this red, for this 8, we can divide, we can give one of them to green and one of them to blue. Right, people who are just new over here, I'll just tell you guys, just subscribe. Okay, I'll just share this video on Discord also because I think like not much people are over here right now. Okay, okay, so I've shared it. Okay, so I think people will be coming right now. And there was I think I see there's a message on like Instagram also. There's a message on Instagram, so I'll just do one thing. I'll just, some guy asked me. Okay, I can't see the message right now. There was a message on Instagram where the guy asked me whether like the link of the video. Okay, okay, so let's get into the video. Okay, so this is a condition where like from the 8 we are dividing one to green, we are giving one to green, one to blue, but the remaining 6 are there, and remaining 6 can't feed on red, right? So this is a condition where there will be no. So now from here we can assume one thing, that we have to find it in such a way that the number of red is lesser than equal to the number of green plus the number of blues. And the same thing happens for everything. Okay, and the same thing happens for all the other colors also. Let's say we have a green over here, so it will be lesser than equal to of that of red plus blue. Okay, and if there is a blue over here, then it's more simple. It should be less than equal to the number of green plus red. Okay, so simply these are the conditions for which it was to satisfy, because over here, over in this case, we were just, sorry, just ignore it. So in this case we were just considering the red butterfly. Okay, but on a whole scale we have to consider all the butterflies, right? We have to consider all the butterflies that are there. So since you have to consider all the butterflies that are there, so you need to focus on the fact that you have to consider green butterflies, red butterflies, and blue butterflies. Okay, so let's get in the code directly, because I am just assuming that this will be clear for you guys if I go to directly to the code. So I'm taking an input of t. Okay, and for that is the test cases, and for every test case I am taking a, b, and c, more like r, g, and b. Okay, you can go for r, g, b, r, G B R G B. अनदर गेम से मेरा कोड कोड समझा के मैं अनदर गेम चला जाऊंगा, ठीक है, कोड समझा के चला जाऊंगा उस पर, ठीक है, छोड़ो। RGB R, okay, so hi. So if you would like do this, you will get the answer. Okay, so that is basically what was there. So since uh, who was it though? Suhail. Suhail demanded for another game only, so I'll just go to another game. Okay, because I'm just assuming that that was a very simple thing. Okay, so let's get to another game. Okay, Alice and Bob have decided to play yet another game. Alice will give Bob a non-negative integer k and a permutation p of length n. Okay, now Bob's goal is to sort the whole permutation in ascending order. To achieve this, Bob can perform the following operation how many times he likes. So we don't have a boundary that Bob has to do it in this number of steps or this number of steps or minimum this number of steps. There is no boundary. Okay, so he can do it in any number of steps. This is a very important concept. You may ask me that why is it a very important concept? Because let's say if I'm not bounding anything that I have to do this within this number of swaps. So let's say I have an element over here, I have an element over here, I have an element over here. Now I want to swap them, these two elements. Okay, this is a very important concept. So did I explain the right? Okay, I'll just do the whole. I'll just explain you the whole question. Then I tell you why it is important. Okay, so you have to choose two indices I and j such that p of I plus p of j is lesser than equal to k and swap p of I and p of j. So we have to find what is the minimum value of k that can we have. Okay, now since we are dealing with the minimum value of k, now here comes the interesting thing. Let's say we need to swap these two elements. Okay, these two elements, but let's say this element, this is x and this value has y. Okay, so if we are swapping them, so what will be the value of x, the value I mean not value of k, it will be x plus y, right? Since it was given in the question, it is p of I plus p of j and it is lesser than equal to k, so I'm just assuming that it is the greatest. Okay, x plus y. But what if there was a over here? In that case we could have swapped a with y, and then after swapping a with y, it will become y and this will become a, right? Then we can swap y and x, right? Then we can swap y and x. Now it becomes x and this becomes y, right? So this is a possible thing. यही समझना था, यही समझना था. So do you get it? Like this thing you have to understand. Okay. So you can do that by swapping this. Okay. Sorry. I made a mistake or what? I was doing this with a and this with x. Yeah, like you don't swap this with. I think this will have a same thing, na? This will be x and y only, right? We will rather swap this and this. Okay. So basically, this becomes a and this becomes x, right? And then we swap this and this, so it becomes a and this becomes y. So basically, this x gets transferred to y, this y gets transferred to x, and this a remains a only. Now this a thing, this a, if you notice one thing, when should we use a? It is the most important thing. Okay, when should we use a? So whenever we were using a, what was the value of k? What was the maximum value of k? The maximum, I mean not the maximum, the minimum value of k. It was whichever was maximum among x comma y plus a, because one operation needed a plus x, right? And another operation needed a plus y, right? Now what is the optimal thing that you can do in order to, so basically it is going to be the minimum, I mean the maximum of them. Okay, but since the maximum of a plus x and a plus y, we can take out a common out of them, So this is the simplified thing. Okay, a plus maximum of x comma y. Clear? Is this part clear with everyone? Just tell me if this part is clear or not. Okay. I think there's some a little bit of lag or what from my side. Okay, I'm back, but the chat is not loading. So just wait. It shouldn't lag, right? Okay, it's proper. It's proper from my side. Okay, it's proper from my end. Sorry for the lag though. Let's get into the video. Okay. So as I was explaining you that since we have to take the maximum among a plus x and a plus y, so basically it is more like a plus maximum of x comma y, right? But this x comma y, these things, we can't change them. We can't change x and y, right? But this a, it is in our hand because we can take any element which will be acting as a pivot, right? We can take any element. Now this a, what is the most optimum thing? How to minimize this? Obviously this a should be as minimum as possible, so I have to take the minimum of a, right? So what is the minimum of a? It is the minimum of the whole array. Okay, it is the minimum of the whole array. So is this clear? Is this clear with you guys? Okay, I'm just assuming that this is clear with you guys. Okay, because this was a very general logic. Okay, now since we have to take the minimum, now we have to find out like what are the values of x and y that we have to take, right? Because it doesn't matter what the x and y are, because if you're swapping x and y, then you will be swapping y and z, or maybe not y and z, let's say some other alphabets. Let's say you're swapping b and c. Then what is the question? The question is uh, this one, another game. This problem, this was a pretty easy problem though. Okay, but the I think the guy who requested for this, I don't know whether he's over here or not. Okay, I was doing this for him also. Like, I don't know. I think he's not over here. Okay, so these things, like whenever we are going to swap them, so it is going to be involved in this maximum only, right? Now comes the condition that how you have to find out like what are the elements that you need to consider for this max. Okay, so the elements that you need to consider for this max are the elements which are not in the right position, right? How to find out what are the elements that are not in the right position? You can take an array, ARR, which is the initial array, and then sort it in BRR. Okay, and for every specific positions, you have to check whether the elements are same or not. If the elements are not same, that means the element at that position is not right, not correct, right? Now based on that not correct positions, only then we do the swapping. Otherwise, we don't do the swapping, right? If the positions are same, I mean, if the positions are correct, then we don't do the swapping. Only if the positions are not correct, then only we do the swapping. There is also another condition that if all the elements are same, I mean, if the array is already sorted, then we don't need to perform anything. Okay. So let me go to the code and tell you like how you have to handle the whole thing. Okay. So I'm taking two arrays, ARR and BRR, as I explained you, and then I'm just taking the ARR input and copying ARR in BRR of I. Okay, I mean ARR in BRR. Then I'm sorting BRR because BRR has to be sorted. That is the final array. Okay, this is the final array, right? Then I'm taking A and B. I don't know what the heck A and B is actually. I was okay. I know what A and B is. Okay, so B is the uh, B is the maximum element which is not in the correct position. Okay, B is the maximum because you can see that I move from n minus 1 to 0, right? Because I move from this position to over here. So the first position where this thing breaks the condition that both of the array elements are same, the first position where it breaks is the first position where it breaks is the position where we can find like the element of BRR of I, whatever is over here, it is a maximum element that is not in position, right? That is a maximum element. So basically based on that we get the B. Now if B is not equal to 0, that means if let's say if B is equal to 0, okay, if B is equal to 0, that means the array is sorted, because if the array is sorted, then only in none of the positions we are going to have an element for which like both the for which BR of I and AR of I differs. Only if the array is sorted, right? But if the array is not sorted, then we can say that this A only, okay, this A only that I was talking about. This is so basically what A and B is. I have taken this as A and taken this part as B. Okay, so I get A and B, and only if B is not equal to 0, then only we have to consider the smallest element, because if it is sorted, it's a direct 0. We don't need to do anything. Okay, so only if it is not sorted, then only we need the minimum element, otherwise we don't need it also. So basically then we do B plus A and we get the answer. Okay, any problem regarding this? If there is no problem regarding this, then I'll go to colorful tree easy version. Okay, if there is no problem, tell me. There are two people watching this. Can you show the code once? Yeah, I'll show the code once. So you have the code. Okay. Is it visible? I think this is okay, right? I think the code is visible for you. Just look at the code. If you have any problem, tell me. Why is the delay? The delay is it visible? I think this is okay, right? I think the code is visible. Just look at the code. If you have any problem, tell me. Why is the delay? So I'm just assuming that by now you have just gone through the code. You can tell me if you have any problem. So let's get into this problem, which is a colorful tree. Easy version, okay. So this is the easy version of the problem. The difference with the hard version is the highlighted in bold. Is highlighted in bold. So the hard version was this version. No? Yeah, hard version was this version. I'll explain the hard version also, but I haven't coded it. Okay. You're given a tree containing n vertices and n minus 1 undirected edges. So basically, you're given a tree. No, it's clear. Thanks. Okay, okay. So basically, you're given a tree. You have to color each vertex of the tree either red or blue or green. Okay. Now, each vertex must receive exactly one color, and there should be at least one vertex having each color in the end. For vertex u, the score of u is defined to be as a sum of the distances from u to the closest vertex of the other color. Okay, so let's say if there are two vertices, like if so it is given like if there is a vertex colored red. Okay, if d1 is the minimum distance from u to a green vertex and d2 is the minimum distance from u to the blue vertex, the score of u is d1 plus d2. Okay, so basically you have to find out the sum of the nearest vertex of a different color. Okay, that's what it has been given in the question. So then you are given the edges and like you can do it. Okay, so let me get into the problem directly. Okay, this was the code now, another game. So I'll just clear this out. Go to this. Okay, let's make this a little bit larger. So let me do one thing. So let me just draw the first tree. Okay, the first tree looks like this: 1, 2, 3. The first tree you can look at over here. There's an edge between 1 and 2, and there's an edge between 2 and 3. The first tree looks like this. Now, if you want to minimize, okay, if you want to minimize the whole thing, so it is very clearly evident that there are only 3 nodes over here, and if you want the like, you have to color all the 3 of them with different colors. Why so? Because if you color something with the same color, then the distance of any one of them, let's say if you're coloring this and this same, okay, and this is different. So if I'm checking for the color 3 from here, it is going to give me an infinite distance. So that is a very bad approach, right? Now, let's say I'm coloring this red, I'm coloring this blue, I'm coloring this green, right? So this is a very optimal approach from our point of view. From my point of view, I think this is a very optimal approach. Anyways, people who are new over on this channel, I'll just ask you guys to just subscribe my channel and like this video, okay? So see one thing. What is the score? What is the total score of this whole thing? Just think about it, okay? Total score for this red vertex, it is going to be 1 plus 2, okay, that is 3, right? It is 3. For this it is going to be 1 plus 1, that is 2. And for this vertex the 3, it is going to be 1 plus 1 2, 1 plus 2, that is 3, right? Now think about this, okay, think about this wisely. So no matter whatever we are having as nodes, right, no matter whatever we are having as nodes, it is always evident that if we want to minimize it, the neighbors of a node should tend to have a different color. Okay, the neighbors should have a different color. Keep doing this, you will be great one day. Thanks, man. So the neighbors are going to have different color, but the main point about this is, so if the neighbors are going to have different color, for this red, whenever we found this red, then why this was a blue, but which neighbor is going to be green? There is no other neighbor of 1 other than 2. In that case, green is going to be the next neighbor, right? And whenever there is a next neighbor, then the value, that the score of the node, is 3, right? Otherwise the score of the node is 2, because for 2 there were 2 neighbors already, right? So if any node has got at least 2 neighbors, we can directly say that for that specific node, we can directly say that the score that it is going to contribute is 2. Otherwise it is going to contribute a score of 3. Is this part clear with you guys? Just tell me if this part is clear with you guys or not. Okay, simple reminder, people new to this channel, do subscribe. Okay, is this part clear with you guys? So I'm just assuming that this part is clear with you guys only. Okay, now let's think about this, that when will a node have one neighbor, or when will a node have two neighbors or more than that, right? When a tree has more than two nodes. When a tree has more than two nodes, you don't need to consider like more than three nodes for two nodes for a tree, because it was given in the question there are at least three nodes. Okay, but if you're talking about two neighbors, then yeah, then that's a true thing, that yeah, it has to have two neighbors. Okay, now basically how we are going to find whether a tree whether a node has two neighbors or not, or less than neighbors. Okay, we are going to find it from the in degree or the out degree, or let's say, like, it's not in degree or out degree because this tree is not directed. Since it is not directed, so it's going to be basically the degree. Okay, the degree of that node. How can we find the degree of that node? From the edges that are connecting to that node. Okay, because if you look at this problem, how many times did we have two? We had two times, right? Since we had two times, so degree of 2 is also 2. Okay, so how, depending on how many numbers it happens in the edge, in the edge, what to say, in the edge array, let's say edge array only, depending on that we have to see, we can say what is the degree of that thing. Okay, so let's, now since we know the degree, now look at it over here. Okay, so for this case 1 and 3 contributes to 3. Check this thing, score of 1 is 3 and score of 3 is also 3, but score of 2 is 2. Why so? Because of the fact that, sorry, so this is because of the fact that um, it has the number of neighbors it is having, or more like, let's say, the degree of that node. Okay, based on the degree of that node. So now we are simplifying it. Let us consider this condition, because if you like get this condition perfectly, then it will be better for you to understand, and like the whole problem will be solved. Okay, so for 3, if you're going to consider for all the nodes, for 3 there are more than one node, right? So the degree of 3 is 3. Now since it is 3, so the score that is going to contribute is 2. For 4 it is 1, so it is going to contribute 3. For 5 it is 1, so it is going to contribute 1. For 2 it is 2, so it is going to contribute 2. And for 1 it is 1, so it is contribute 3. So what is the answer for this? It is going to be 2 plus 3 5, 5 plus 3 5 8, 8 plus 2 10, 10 plus 3 13. If you look at the question answer, it's 13. Okay, so is this part clear? So I'll be explaining you the question part because there is a lag. So by if it is not clear, just tell me. Okay, so the vector int, I'm taking a frequency, or more like this is a degree array only, degree. And then for all the edges, I'm going to consider, I'm going to increase the degree. Okay, increase the degree basically. I'm increasing the degree for x also, and degree for this also. Okay, and then I'm taking the value of answer as 0 initially, because answer is going to be the sum of that. Now if I'm finding that frequency of that is 1, so if there is a degree of 1, then it is going to be answer plus equal to 3, otherwise it is going to be answer plus equal to 2, right? That is what we were doing basically. Now nothing will have a degree of 0 because it is a tree. Okay, since it's a tree, so nothing will have a degree of 0, so we don't need to consider that. You may ask me that why didn't I consider frequency of I equal to 0 or not? Because this condition will be there only when it is greater than equal to 2, right? So we are left with 0 also, but 0 is not possible in a tree. So that's the reason we didn't consider that. So is this part clear with everyone? So I'm just assuming that this part is clear, okay? People who are new to this channel, it's a genuine request for you. Just subscribe my channel and like this video, okay? Okay, so since this part is I'm assuming is clear, so I'll move on to the next problem. Yeah, okay. Xometry. Okay, it's geometry, whatever it is. Okay, I don't know whatever it is. There's the easier version of that. Okay, you're given an array containing n non-negative numbers. Already subscribed. Thank you, man. Thank you. Okay, so you're given an array containing n non-negative numbers. Count the number of ordered quadruples I, j, k, l such that we can make a rectangle ABCD where AB is equal to A of I into A of not into A of I XOR A of J, A of J XOR A of K. So basically this is what it was given. So you can directly go over here only. So I'll just copy it in an Excalibur draw if I can. Yeah, I can. ये नहीं हुआ था contest में. अब देखो हो जाएगा एकदम heavy था ये वाला. Good question. Like good question from my side. I feel what I feel about it is because now see very interesting thing. If you notice this, A of I and A of J, if you XORed it, it is equal to A of K and A of L. XORed. Right. Now, A of J or A of K is also equal to A of L or A of I. Which basically means, now just think about this, okay? Now just think about this. If these two are equal, okay, so since I won't be writing the A again and again, okay? So I XOR J is equal to K XOR L, right? This is clear. Now, if I XOR J is equal to K XOR L, and I make this, and I XOR both sides with J XOR L. Okay, I'm going to XOR both sides with J XOR L. So basically, for this side, this J and J cancels out, right? So we are left with only L, right? That is A XOR L, I XOR L, and over here, this L and L cancels out, and we are left with J, right? So that is K XOR J. Now look at this thing very minutely, okay? A of L, A of I, that is this. A of J, A of K, that is this. Which basically modifies the problem in such a way that you don't need to consider these things. Okay, these were not considered only. These were not our main concern only. These were not our main concern. Our main concern were these two. Okay, or more like these two and not them. So we didn't have to find the quadruple. Okay, we had to find a pair. Do you get it? We had to find the pair, and we had to find two pairs. We had to find two pairs for which the XOR is equal, right? Because this is a pair and this is a pair, and the XOR has to be equal. So I just now proved that only these two were the things that we needed to consider. These two were not needed. These two were not needed only, right? Now, how can we do this? How can we do something like how can we perform this thing? Okay, how can we find how many pairs are going to satisfy this? We can do this in a very simplified manner by considering, like, we are going to take some map. Okay, we are going to take an unordered map. So let's say instead of considering, whenever we take a map, what we do is we store the elements that has come before that, and the element which is presently over here, we compare that element on the basis of the previous elements, right? Because the map has this element and we can just compare it. Now, in spite of storing the one dimensional array, we are going to find a kind of two dimensional array. How? Let's say for every value of I have XORed j. Okay, I have XORed j. Now it's done because I have XORed I and j. For every value of I have, and for every value of j, I have done it. Now, when I am coming to k comma l, okay, remember this. Okay, so let's say I have computed I and j for all the values. Now, when I come to k comma l, we know that these two values are not equal. Neither these two values are equal, right? Now, since we are now over here at this position and we have to XOR them, so this XOR happened before this XOR, right? This XOR happened after, so this one happened before that, right? Now, since this one happened before that, we can say one thing very clearly, that we can store this in the map and find its frequency. So, what is the map going to be? The map is going to be a frequency map. And then we encounter this. When we encounter this, we are going to consider this pair with the number of pairs which gave us a XOR of this, more like the XOR of this, because the XOR of both has to be same. I think it will be better if I show you the code directly. I'll just show you the code directly because that will make the whole thing clear for you. So see this, okay. So I am taking a map of size 2 to the power 22. Why is 2 to the power 22? So basically, if you look at this value, 10 to the power 6, and I don't know whether I can have a calculator or not. No, I don't. I want the calculator. Can I have a calculator? Yeah. So if you make 2 to the power 22 and find the answer, it is going to be 123 123. So that is 4 into 10 to the power 6, right? What if I am sorry? What if I am interested about 2 to the power 21? It is basic. It is basically 123 4 5 6 2097152. What if now notice this? Okay, what if I made 2 to the power 20? Okay, to the power 20. The value is 1048576. So this value, if you look at it, so what is this value basically? This value is of the range 10 to the power 6. It is more than 10 to the power 6, right? So basically, you didn't need this 20 to do it. 20 would have done, okay. But I was just like overthinking about that because I thought about the limit. So that's the reason I kept 22, but just 20 would be fine. So using this for all the maps, you can compute it, right? But think about it. Think about this thing. Okay. Now, if we are computing the whole map, so we can find out whatever the XOR values can be, right? So, in spite of taking it as a map, because a map, like finding something from an unordered map, will be a little bit difficult and may give you a TLE. It was giving me a TLE in the last two test cases. So, basically, it will give you a TLE. So, it's better you take a vector only and use it as a map, because you can use a vector as a map by initializing it as all the elements as 0, right? Now you're going to check that For every value, you're going to XOR it and check how many elements are having that value of XOR, of that XOR value in the map, and you're going to add that to the answer. Okay. Once you're done with that, then you are adding the XOR values into the map, because now you've computed the answer part, and now you have to just consider the XOR values, right? Because now you computed the answer part. Three people are watching this. Three people. Why are there so less people today? I don't know. Anyways, we have 1.81k subscribers right now. No? Yes, makes sense. Clear? So basically, that's what we do. This is plus plus only. Okay, this is plus plus only. Plus equal to one LL. This is plus plus only. But I just took LL because I don't know na. Now you can see one thing, that after I have performed the whole thing, I am multiplying it with 8. Now you may ask me why 8, right? Why 8? Why 8? Let me tell you why 8. Because it was given that all the pairs are valid. So if instead of taking I J K L, I J K L, I could have also taken I J I K L, right? J I K L, right? Just the fact is that this to XOR and this to XOR has to be same. Now since the XOR of these two and these two have to be same, and we are basically focusing on the pairs. Okay, we are basically focusing on the pairs. So what is it going to be? It is going to be 2 factorial, because there are two pairs that we are considering, right? It has to be 2 factorial. But within that pair also, there are two members, right? There are two members. So basically it's going to be 2 factorial into 2 to the power 2. Is this clear? Is this permutation logic clear? Because there's a pair. So for every pair, it is 2 squared, and for since there are two people, so it's 2 factorial. If you compute them, it becomes 8. Okay, it becomes 8. And if you find this logic to be a little bit difficult, so I'll just explain you. The first number can be any one of these 4. So that is, let's say there are 4 numbers. Okay, so the first number can be any one of these 4, and based on that, the second number will be there, and this number can be any one of the remaining 2, right? Of the remaining 2, and this number will be based on that. So if we multiply 4 and 2, it becomes 8. So this also makes sense, I guess. But this is a more mathematical approach. But this is a like a naive approach. Okay, it doesn't matter whatever approach you follow. It matters whether you get it or not. 2 to the power 4 by 2. You're going to like, okay, yeah, that also makes sense. Why? I'll just tell you why that makes sense. Because for every specific element you're considering, you're considering it as 2 to the power that. um I I haven't like, okay, I'll just show you this. Okay, this Xometry hard version, I was solving it. I had solved 3 parts only, but I haven't solved the remaining parts. But I can explain you, okay, because I think I know where I went wrong. So I'll explain you, but I'll also go to the editorial and check whether my explanation is right or not. Okay, so yeah, I'll explain you. You can wait. I'll explain that. Okay, I can explain you. Okay. Same with you. Okay, that's good. That's good. So we'll do it together. Okay, we'll do it together. Done. By the way, what is your rating, Hema? So is this question clear with you guys? This Xometry easy version. Is this clear with you, everyone? If this is clear, then we'll go to Xometry hard. Okay, just tell me if this is clear or not. Okay, 1987. You have a better rating than me. You have a better rating than me for real. Hema Kothari. I don't know. Like you all have 5-star ones. That's damn. That's damn. I've never been in the 5-star thing. Okay, this is your mom. Okay. Okay, okay. Shreyansh. Okay, Shreyansh. Even I was thinking that. Like, okay, no comments. So let's see a solution of a person once. Okay. Ah, count of V of I into count of V of J. CTRH. This one. A colorful tree hard version. Okay. The hard version. I'll just use the editorial. Okay. I thought breaking it in a problem of either all four are same or C two. Yeah, even I thought of something like this, but um, I think that works also because that is the only condition when it is like that. Okay, but what I did was I found a pattern. I broke a pattern in this. Okay, so the pattern was basically like this: uh, x into 4 plus 1. There was a pattern like this. Okay, what I broke out. So if you look at this pattern, it becomes 5 and 21 and something like that. So that is a pattern that I broke. But exactly, I was also trying doing the same thing as you did. Okay, so I think we both got stuck at the same place only. So it's better like if we solve it together only. Okay, it's better to solve it together, right? I can look at this, but I'll just look at the editorial. Okay, first I look at the editorial. What the editorial tells us. Okay, so you're given an array A of n integers. Count the number of. Okay, that's the question only. It's given that you read the. Okay, I haven't read it. I mean, I haven't read the solution because I have done it. Okay. So why would I read it though? No, I'm just kidding. So now that A can contain duplicates, our only issue is certain side length becoming 0. Okay. We have to subtract out the back tuples. Some two adjacent elements of tuple must be equal. So do you get this? Do you get this? I think this is clear. I didn't think it this way only. let's look at the author's code. He did the normal thing. He did the normal thing. Anyways, he did the normal thing. And then after that, answer into equal to 8. I don't know what. I think the editorial code is what I need. For x in A element frequency, this is x in A, y in A, frequency of x is equal to, this is 0. Okay, he's just taking the frequency of everything 0. And then for every element, he is just answer minus is equal to x into x minus 1 into x minus 2 into x minus 3. So let me just check out like how many back tuples are there. Okay, because I think it was only, most importantly, that was only needed. Suppose all four elements are equal, then there is no valid way of reordering the indices. All XORs will always be 0. Such a tuple has been counted 24 times. Okay, but should be counted 0 times in reality. Okay, so you have to find out how many ways you can have all the four elements equal. Okay, first thing, suppose a of I is equal to a of j, then a of I or a of j is equal to a of k. We must also have a of, meaning this. So we have two pairs of elements, let's say xx yy. We assume, since otherwise it goes back to the first case, has been counted 24 times, but only 8 of those are actually valid. So basically some of the, like if all the four elements are same, you have to directly get them out. And if two elements are same, then you have to get them 24 out and add 8 to them. That is what the basic, what that is what basically the thing is all about. Okay, now let's see. Now when they are subtracting the tuples, for each element x, there are f of x 4 ways to choose 4 distinct indices containing x. Each one of these should be subtracted 24 times. So subtract 24 dot this from the answer. 24 dot f of x 4 from the answer. Okay. This takes big O n time interval, since we only care about the distinct values of x that appear in x. For each pair of distinct pairs, x lesser than y, they have f of x into 2, therefore y of choosing 4 tuple that indices. Okay. So each of these has been counted 24 times. This takes big O n square time. So basically, I think it's better like if we have another map over here. Okay. So I'll just do the code in front of you guys only, because I'm myself not sure about that, whether I'm doing it the right way or not. I'm taking a frequency thing. Okay. And then for every element, I'm taking the value from I less than n, I plus plus, frequency of a of I plus plus. Okay. Uh, Now one thing that I will tell you guys about this is that since they are taking out 24 of them, and in the next case they are taking out uh, 24 minus 8 of them, that is 16. So basically at a later stage we are multiplying it with 2, right? Sorry. So basically if we divide this 16 by 8, it is 2, and if we divide this 24 by 8, it is 4, right? So basically we are focusing on 4 and 2 only. Okay, we are focusing on 4 and 2 only. So I'll just check if this works or not. Okay, for int I is equal to 0, I less than n. Now it's not I less than n. will be I less than equal to this value. Did I take 22 though? Yeah, I took 22 only. But I think 20 will work also, right? Or should I take 22 only for now? Okay, because I don't know whether it will work or not. Let me take from 0 only, which is not needed though. So if uh, frequency of this thing, frequency of I is greater than equal to 4, because if there's a frequency, so let me just put it over here so you guys can see it very easily. So if the frequency of this thing is greater than 4, then we are going to, from the answer, we are going to subtract 4 into that C4, right? So basically the denominator will be 3 into 2 into 1, that is 6. And the numerator will be frequency of I into frequency of I minus 1. I mean, no, frequency of I minus 1 into frequency of I minus 2 into frequency of I minus 3. I minus 3. I minus 3. How to manage college and CP? You don't have to manage college. Best answer. You don't have to manage college. Was the frequency long? No, it's int. It's int. And this value can be long, no? Oh, I think this will also be int. For now, let's go with int only. Okay. So this is one thing. Okay. Now there is another part of the thing, of the whole thing. That is, what if there is also another j for int j is equal to 0, or not 0, because we are going to consider for the remaining part only, j less than this, j plus plus. If frequency of I is greater than equal to pi, if this is greater than equal to and frequency of j is greater than equal to 2, in that case, path you were asking me how to manage college and CP, right? See, the CP contest, like they happen uh, on Sundays. They happen like mostly. What I focus on is lead code weekly challenges. That is on Sunday 8 a.m. And sometimes if, like the Codechef also happens like on Wednesdays. And if you are doing CP like professionally, then you will be like not professionally. Like if you are very interested in CP, then you will be like liking this thing, that is code forces. So the code forces doesn't have a perfect schedule. So if you're considering code forces, then it's kind of difficult for you to handle it. But if you're doing only Codechef and lead code, so you can give 2 days of your week to CP and the remaining days, because it's also going to benefit for DSA, which is also there in your college syllabus, right? So that's it. Now this thing, since we have to multiply it with 24, now that is going to be NC2 into NC2 by 24 into 24, right? So this 2 and 2 cancels out. So if you divide this with 24, it becomes 6. Okay. So 6 into frequency of I into frequency of this into frequency of j minus 1 into frequency of j. Uh, I think I did the right thing only. So I will just wait a minute. I'll just keep this thing, or more like I think I made a mistake. I should have kept it over here only. I'll just run this. It's having time limit exceeded. Right? While having time limit exceeded though. Okay, we didn't need to consider this, right? We didn't need to consider this. We need to consider only n. This I will be replaced with AR of I. Okay, so I will be replaced with AR of I. So let me do one thing. I'll just copy this, paste it over here, paste it over here, paste it over here, paste it over here. And similarly for this also, I'll just do the same thing. I was just considering for all the elements, but I don't need to consider because all the elements are already there in the array, right? Control V. This is going to be Control V, but this is going to be J. Control V, Control V, Control V, J, and Control V. And this is J. Sorry, not K. J. So if I run this, I don't know whether this is going to work or not. It's minus 624 minus 1296. Factorial. What am I doing wrong? The previous one was factorial of that, na? It was fx4, right? 24 into fx4, like 4 into 3 into 2. What is it? 4 into 3 into 2? It is 6 fours are 20. Oh, it's 6 fours are 24, man. I didn't need to divide this only. I didn't need to divide this only. It's coming 624. Since I'm multiplying it with 8 later on, right? So I have to divide it with 8 only. This thing I have to divide it with 8. Or more like, I don't know whether heck am I doing it wrong. I'm taking it till greater than equal to 4, and then after this is going to be more like there are this number of ways of choosing a 4 tuple, and so subtract 16 of them. Now if I'm going to take 16 and divide by 4, it becomes 4. So I was doing something real wrong with this. Okay, I was doing something real wrong with this. I'm just assuming that it should be right now. It's minus 12 and 234. Let me look at the question first. Okay. Minus 12 and 234. There's a difference of 16, right? There's a difference of 16, which means it's coming from here only. It's coming from this part. So in this case, if I'm not considering this only, okay, if I'm not considering this, let me check, okay. If I'm not considering this, what is the answer? First, let me check. The answer is 48 and 384. So we have to reduce 40 from that, right? We have to reduce 40 from that. Now, based on what it was given, it will be 24 and 16. I think if we add both of them, it becomes 40, right? If we subtract both of them, it becomes 40. I mean, yeah, it becomes 8. But over here, we are having only two twos and two fours. That is 16 into 2C2 into 2C2. Okay, that is 1. So I'm just removing 16 from 48. Right, I'm just removing 16 from 48. If I'm not wrong with my concept. But over here it is showing us that we have to remove 8 from it. I mean, not remove 8. We have to like give it only 8. So if we add this 8, just wait, I'll just use the calculator once. If we add 16 to 8, it makes it 24. So basically we were having this. Okay, one more thing I forgot. That was this. I didn't have to like consider the elements which were already there. Okay, I didn't have to consider them. So I'll have a new vector over here. Okay, a new vector over here, which will be called, let's say, this was ARR, right? So now I'll just name it ARR now. Okay, so let me name it BRR. Uh, then I'll just sort it out. Sort BRR comma BRR plus N. So I'm just removing the duplicates over here. Okay, if you guys don't get it like what I'm doing, I'm just removing the duplicates. And then for int I is equal to 0, I mean not 0, 1, I less than n, I plus this. If AR of I not equal to AR of I minus 1, that means it is not repeated, it was not there. Then AR dot push back BRR of I. So what I made a mistake over here, it's going to be BRR. Okay, now I think it's okay. And then I have to also push back BRR of 0, because the first element will always be there, right? Now there is a new value of n. So that is n is equal to BRR dot size. Is this going to work now? It's going to give me a compilation error. Why? Frequency. Okay. Yeah, the frequency thing, it was done well before that, so it will be BRR. Yeah, that's a mistake from my side only. Compilers are not like compilers don't make mistake, no. Walk. Okay, so it tells me n is equal to BRR type n. Right? Remember size in BRR which is of non-class type int n. Okay, I was also sorting the wrong thing. No, I sorted the right thing. I sorted the BRR only. N is equal to BRR dot size. Okay, no, it's going to be ARR dot size. First of all, it's going to be ARR dot size. And there was an error over here, I don't know what. No match, vector int and int. So it doesn't work sometimes. I don't know why it is not working right now. So I think by doing this, it should work. Like if I'm using begin and end, it should work. What is happening, man? I don't want to sort it again, right? This is not needed, right? I don't want to do this. But why can't I sort BRR? What the heck is happening with this, man? Why can't I sort BRR? Anyone, any idea why can't I sort BRR? Just help me out. Okay, now it got sorted. But the answer is wrong. Okay, now the answer is wrong. Now what we are going to do is, I know why the answer is wrong though, because we didn't do this, right? It is 0 and 24. Why is it 0 though? Because it's going to be 2 and 4 only, solely 2 and 4. So if we are removing the duplicates and we have a 2 and a 4, it's such a pain in the ass. 8 and 104. What the heck is wrong with you? Okay. I know why. I know why. What about this? 0 and 24. No. Okay, I forgot to comment these lines out also. Minus 2 and 70. I think it's better like I just copy the solution that was given in the editorials. But okay. And I'll explain you. I know this. Like I can explain you this. Because you know what happens? Like sometimes it's like sometimes you don't get the thing. Okay, sometimes it happens. So I just prefer just doing with the editorials code only. See what this guy does is he's taking a frequency array of 0 into m and 0 element frequency of 0 into m, and this is the test cases only basically. Then he's taking n ARR, and for every range he's checking out this frequency, and then every range. Okay, okay. List of set A, length of distinct I in Z, etc. So is it like I think I get it. Do I get it though? I don't know. Do I get it though? This part is normal. This part is normal. The frequency thing. I don't need to cancel out these things. Okay. I don't need to cancel out these things. ERR is going to be ERR only. Okay. I don't need to cancel out them. I'll just try doing this. If it doesn't work, I'll just go back. Okay, I'll just go back. I won't do that again. So don't need to worry about that. Frequency of BR of this, frequency of blah, blah, blah. I'm taking ARR, I'm taking this, I'm taking that, I'm taking do blah, blah, blah. Then for int j is equal to 0, j less than I, j plus plus. For this I have to consider doing this, and for this I have to consider doing this. Then for every n I am doing this. Okay, in this part I need what? I need this. Okay, or more like, I think what I feel is, since I was doing that earlier, I had this done earlier also, so I won't make this thing value of this as n, so I'll be doing this on BRR only directly. Okay, so that will make it easier for me. If your brain goes boom, I'm sorry bro, because this is how I code. I'm so sorry, this is how I code. Too rough, like, even sometimes I don't understand what I'm coding. Okay, so yeah, that's the thing. Now n is equal to air dot size minus 258. No, I won't risk it. I won't risk it on it. Okay. So I'll just show you what he has done. Okay, so he's taking the frequency for all the range, and he's adding 1 to that. Okay, and for the remaining parts from I plus 2 to n, why did they take I plus 2 though? They could have taken. Okay, he's just adding the frequency of that to it. Frequency of a of I plus 1 to a of j. I'll do it again. Okay, I'll just do it again. I plus 2, I plus 1. No, it's not gonna work. Okay, so let's check this. Okay, let's check this out. So what he does is he's taking the frequency of I and j, which is happening before I. Okay, so j happens before I. Actually, this question is like that. No need to say. Yeah, I get it. So basically, what is happening before I? He's taking that as j. Okay, so he's taking it like this. Okay, he's taking a j. Sorry, he's taking a j. Then he's taking I. Then he's taking I plus 1, and then he's taking k. गाना आता तो सुना देता ना भाई, नहीं आता हुआ गा नहीं सकता मैं. Okay, so for every that pair he's considering it as plus 1, and then for every this pair he's going to add that answer to it. Okay, he's just adding that answer to it. Now whatever the answer is, he's just multiplying it with 24. Okay, whatever the answer is, he's just multiplying it with 24. He's just multiplying it with 24 instead of multiplying it with 8. I was doing it with 8, but he's multiplying it with 24. Is that going to do me any good? I don't know. Is that going to do me any good though? No. It's 14 and 234. It doesn't do me any good, but I think I know what he does is basically. So for all the remaining pairs, he's just checking for answer. Okay. Now based on that, after he has done with it, then for x in all the element, he's going to increase the frequency of elements. Okay. He's going to check for the frequency of elements. Now, then he's making all of them distinct. Okay, all these distinct. He's making all of this distinct, and then he's checking the size of the distinct because he's just taking away all the element duplicates. Okay, and for every distinct element, as I was telling you that since let's say if there are four things. Okay, if there are four numbers having the same side, so we can take any value of this and pair it with this. We can pair any value of this with any of the values. Okay, so that is we can pair this value with three values basically. This value we can pair with three values, right? And the next value we can pair with two values, and the last value we can pair with one. So basically, if you are going to consider the permutation very minutely, it is going to be 4 factorial. If all of them are same, right? Because if all of them are same, you take any pair from that. You like if four of them are same, you can take any pair from that, and it is going to have the same thing only, right? Sumant, hi, bro. Now, since this is four, like we can do this in 4 factorial ways. What is 4 factorial? 4 factorial is basically 24, right? So whatever ways are there like this, because we know one thing that if you are going to consider a rectangle, any side of the rectangle can never be zero, right? It won't be zero. It doesn't matter whatever it is, but it won't be zero. So if all of them are same, so both the sides will be zero. So we can't consider that. So after considering all the good tuples, he's taking away all the bad tuples. So from them, if he's taking all the four elements same, that makes it a total of 24 possible ways. But if he's taking two elements same and the other two elements same, then he can take these two tuples and these two, right? I mean not tuples, these two pairs and this pair and this pair, right? And if since both of them are same, so it's going to give you a XOR of 0, and this is also going to give us a XOR of 0. So this is also not possible. But this is having a twist over here. That is how many times we are performing this. Because this is not performed every time, right? So this is basically performed 4 into 2, right? Because the let's say like this. So let's say there are 4 elements. So if this element we know, so this element can be any one of them two, one of the two, right? And based it, okay, let's not say not one of the two, this can be any one of the four elements. Okay, now based on that, this element is fixed because this element will be what this element is, but this element can be any other of the twos, so that is 2, but this element is fixed, right? Now one more thing, we can take this and this, we can just reverse them, right? So that is 2, so 4 into 2 into 2, that is 16, right? So we have to not consider 16 of them from here also. Okay, so do you get it? Like how many back tuples are there? What he was basically telling us, back tuples means that if any of the side is becoming 0 or not. So if any of the side becomes 0, it's a back tuple directly. It's straight off a back tuple. Okay, so I think this 24 was clear, and this thing happens like 2 2. Okay, this happens 2 2, and this normal basic calculation. Okay, now if you look at the code that he has provided us, he is just subtracting x into this. Now you may ask me that why is he subtracting this? Okay, it should have been like NCR, like everything goes like NCR only, right? It goes like NCR. So if there are n things among which he has to choose only 4 things, okay, so it has to be this n can be broken like n into n minus 1 into n minus 2, right? Into n minus 3 by 4 factorial, right? By 4 factorial. But since I told you over here, if 4 of them are same, so they are 4 factorial also. This is also 4 factorial. So basically when we multiply this with 4 factorial, this 4 factorial and this 4 factorial get cancelled out. So we are just remaining with this only. So that's what he has done. He has just subtracted this from here. And for all the other pairs, for all the other pairs which were having two of them, okay, whenever there is two of them, guys, be a little bit interactive in the live chat, okay, so that it's better for me to like, understand. Because sometimes, since you know that today there was a kind of lag and then I got disconnected, so just be kind of interactive, okay. Then for other pairs, he's checking if there are like two pairs which are having this thing, this condition, okay, this condition, 2 2. Then what is it going to be? It is going to be 16 into NC2 into MC2, right? Now, what is the denominator of this? It is going to be 2 factorial. And what is the denominator of this? It is going to be 2 factorial. And the numerator is going to be n into n minus 1. And similarly for this, it is going to be m into m minus 1, right? So this 2 factorial into 2 factorial, it becomes 4, right? It becomes 4. So that is basically 4. 4 into n minus 1 into m minus 1. So if you look at what he has done, he's taking off 4 into m minus 1, n into n minus 1. And then he's printing the answer. So now tell me one thing. Is this thing clear? Tell me just one thing. Is this clear? Is this thing is clear or not? Okay. Guys, I'm waiting for your answer. If this is clear, then only I'll just move on to the last problem that I'm going to solve, because I think pair tree औकात से बाहर है भाई, औकात से बाहर है, नहीं होगा please. But I felt that these were easy. That's the reason I was doing this. Okay, otherwise I wouldn't have done this. I would have been like, I'm not going to explain anything. I'm just done with it. So if this is clear, okay, just tell me quickly if this is clear or not. Clear. Good. So should I move on to the next problem? I think I should. How many you solved? I didn't solve much. I solved just 4 of them. I just solved 4 of them. But I was solving the Xometry hard version. Okay, so this thing. So I was solving that. You can do that. What I feel is that that was a nice question. Zero to I plus 2 to n. 0 to I plus 2 to n. Which one do you want me to explain? Which one do you want me to explain? Tell me. Why editorial final answer is multiplied by 8? Final answer is multiplied by 8. I was telling you guys that only. If you look at the permutation, okay, if you look at the permutation for 4, exactly. If you look at the I code note, so I don't know your name though. So what you can do is you can after I end the live, you can watch the remaining part of the live, and after I end the live, I have discussed the whole thing. Okay, I have discussed the whole thing earlier. You can check at it, but I'll just tell you quickly. So let's say if you have 4 positions, so in this position, in the first position, from these 4 elements, you can take four numbers, right? And based on that, this pair is filled. So over here, you're left with only 2 elements right now, and based on that, this element is filled. Okay, so basically, if you multiply them 4 into 2, it's 8. Okay, so that's how this comes. I hope this is clear, right? Anyways, new global. Good night. Well, I'll go to sleep, man. It's 11:52. Okay, I have to. Even I have to sleep. Is there any contest tomorrow? I don't know actually. Is there a contest scheduled for tomorrow? 2424 2424 2424. Answer is equal to this. Then he takes answer equal to this. Goes for this. He goes for this. He goes for this. For J in this, he goes for this. For J in range this, he goes for answer plus equal to frequency of this or of J. I don't see what is so wrong about this. And then he increases the frequency of everything. I do that. Then he makes it distinct. Even I do that. Then he goes for all the distinct elements. Even I do that. I do exactly what he has done, right? Or not? Do I do everything that he has done exactly? Yeah. Is there anything that I'm doing wrong in the next part? I think. Anyways, code node. I'm just waiting for you. Just can you tell me if this like whatever I explained is that clear for you? I'm just waiting for you though. If it's clear, then I'll just go to the next problem. Okay. Okay. Holy crap! Holy crap! Holy crap! I was doing just the plus. So this. If this okay, this works. So I was doing this plus, man. Oh, time limit exceeded. Time limit exceeded. I think I know why. Because I'm taking this 20 and this is 20. Check clist dot by. I didn't get you. What do you mean by clist dot by? It gives me time limit exceeded, but I know like it works. Okay. Now if I have to do that, I'll just need to do that again only. But yeah, it works. I don't have the energy to do that. Okay. I can ask Chat GPT to optimize this code for me. I mean, not optimize, just check what is wrong with it because I'm too tired to do anything, man. I'm done. I'm simply done. Let's go to the next problem. Okay. The last problem that I'm going to discuss. That has a compilation of all the content on popular clist dot by. Okay. So I'll just check it. Clist dot this one. Okay, you meant dot. I get it. Yeah, this is nice. This is nice. This is a nice thing. So someone just had this thing. Okay, this starts in 4 days. It that has a compilation of all contests on popular platforms in the coming days. That is okay. I don't know. Have you guys checked this or not? There is a thing called Code Clock. I don't know whether you guys have checked it or not. Codeclock.in. So is it somewhat like Code Clock? I have this app in my phone, but I think my Code Clock is not giving perfect notifications right now. So they have to fix it. So, anyways, let's go to the next problem, okay? Because we have been waiting on this problem a long time. Colorful tree problem, that is the hard version. So, whatever, like the difference is the highlighted in bold. So, what the difference is? Sorry. The difference is that let M denote the minimum possible beauty of the tree. So, if you haven't seen the easy version, I'll request you to go through the easy version also. Okay? So let M denote the minimum possible beauty of the tree across all valid colorings. Count the number of valid colorings that attain a beauty of N. This value can be large, so compute it modulo 10 to the power 9 plus 7. Now, if you remember this, okay, I was explaining you. So this can be a tree, right? Let's say we have a tree like this. So this can be of any three colors, right? This can be of any three colors. Now, based on this can be of any two colors, and this will be of only one color remaining. That is remaining the remaining color. Okay. But what if a tree is like this? So anyways, if it had more branches from here, then these will be having three. Okay, this will be having three because they are independent. Because if it is independent, we can like it can have any color that it feels like. But otherwise, what we have to do is we have to like have all its neighbor having different color, right? That was what our aim was. So we have to have at least two neighbors with two different colors. But if we don't have only two neighbors, then the next neighbor is going to have that color, right? That was our main aim. So basically, based on that, for this, so there are three ways to color this. And in order to color this, how many ways are there? You can color it in any of the ways. Okay. And over here it is 1. So that is 3 into 2 into 1. So basically that is 6. Right. Now if you look at the question, this thing this is what I explained right now. This thing, okay, that is 3 into 2 into 6. It is given, okay. Now, if we're going to consider this 3, 4, 5, 3, 1, 2, which means 1 is connected to 2, 2 is connected to 3, and 3 is connected to 4 and 5. Okay, so this is connected to two more nodes. Okay, this is connected to two more nodes. Now, since this is connected to two more nodes, so what the value of this can be is our main concern, right? What the value of this can be. Now we don't know what the value of this can be, but we know one thing, that since we have this value till now, so that the value of these can be 3, right? The value of this can be 3 because that is the like the topmost thing, right? That was happening. So if we multiply them, right? If we multiply them, it becomes 3 into 2 into 1 into 3. I think that is 18 only. I think that satisfies, right? So that satisfies. Now this was more of a permutation combination thing. Over here also it is like 3 into 2, something like that only. Okay, everything is having like either a node has a 3 or a 2. Okay, or a 1 also sometimes it may have. So if we look at it, okay, explanation, we know from the easy version that each non-linear vertex has a score of 2, and each vertex of the it has a score of 3. We know that. Okay, the count the number of, you'll use dynamic programming, because I know, because like if you see, like this is dependent on this, right? So everything is dependent on something. So basically I had a thing that I was thinking that dynamic programming was will be the thing. Suppose we are trying to color vertex u after having processed all its children. Call a vertex fulfilled if the current coloring already gives its maximum possible score. Okay, there's an exception. What is the exception? Leaf vertices that are at a depth 2 from u. However, such a leaf vertex will be fulfilled if and only if its parent is also fulfilled, and this parent is a child of u. Okay, so this is a exceptional case. Okay, I won't discuss this. I won't discuss this because this is not as easy as I thought it to be. Okay, this is a hard problem. This is a hard problem. So I won't discuss this. I'm sorry, guys. I won't discuss this. So just tell me if I should end the video or not. Okay, just tell me if I should end the video or not. People who are watching this, should I end the video or not? Tell me. Tell me if I should end the video or not. Uh-huh. Okay, I'll just end the video. Okay, because I think not much people are over here and there are not much responsive people, so I'll just end the video. So that's it from my side. Thank you.